So today we are going to be talking about graphing log functions. So before we begin, we have to be talking about exponential functions. So right here I have an exponential function, 2 to the x power. Exponential means that I have a power that has an x. So when we want to graph log functions, the easiest way to do it is know that the inverse of a log function and vice versa is a exponential function. So if we read it, f of x is equal to b to the x power. This is the exponential function. Then the inverse of this function is log b of x. So this is going to be that. So when it asks us what is the inverse of f of x when it is 2 to the x power, that is going to be simple. All I have to do is follow along to the equation right here. So my inverse, remember this is a sign of inverse, is going to be log. My b is 2, so it's going to be a little b base of x. Cool. So when we move on to question 1, it says graph our original and our inverse. So we know for a fact our original is going to be y is equal to 2x. So let's go ahead and mess with this one first. If we were to plug in our x's into our equation right here, 2 to the 0 power is going to be 1. 2 to the first is 2. 2 to the second, so 2 times 2, 4, and 2 to the third. 2 times 2 times 2, 2, 4, 8. Then we go backwards to the -1. That means we're just going to flip it, and our numerator is now in the denominator, so it's going to be half. And same thing with our -2 to the -2 power. 2 to the 2 power is 4, but we have to bring it down because it is negative. So it's going to look like that. So before we graph it, let's go ahead and actually talk about how to get this function, which is our log one. So remember, this is our inverse one. Easiest way from previous chapters that we get an inverse, easiest way is to switch your x and y. So I'm going to go ahead and switch my x and y. So now my y's are not going to be my x's. So I'm going to write those down. And my x's are now going to be my y's. So I'm going to write those down. So if we go ahead and graph it, all my points for 2 to the x power, I have at -2 it is 1/4, -1 it is half, at 0 it is 1, 1 it is 2, 2 is 4, and 3 is 8. So when I graph this, remember we have an asymptote at y equals 0, so it's never ever going to touch 0 at y equals 0. And we go ahead and do the same thing for the log one. So I start off at -1/4, 1/4, I go all the way to -2, half, I go to -1, 0, 1, 2 is at 1, 4, I am all the way up at 2, and at 8, I'm all the way up at 3. So when I go ahead and draw my function, we see we have an asymptote at x equals 0. So the opposite of what my exponential function is. My asymptote is at x equals 0. So the way you know you did this correctly is when you have a perfect symmetrical reflection across y equals x. So let's just answer a few more questions. For domain for our blue graph, our exponential, from left to right, it's going to touch every single value, so all real numbers. My range, it's only going to be above 0, right? So my range is my y's, so it's going to be y is greater than 0. if we take a look at our inverse function, the log one, it's going to be similar. So for domain, we read it from left to right. But in this case, we're not going to go anywhere in our negatives. So it is only going to be x, because domain is x, greater than 0. Range from bottom to top, it's going to touch every single value. So all real numbers. So it's kind of flipped all over the place very symmetrically. So in our graph, it's perfectly symmetrical across y equals x. Our domain and range look like they kind of flip, but remember domain is x's, ranges is our y's. And in our table, we can totally see, hey, my x's and y's flip. So this is a pretty symmetrical looking kind of function. So we take a look at number 2. So it asks us to graph log 3 of x, right? Base 3x. But it's a lot harder to think of these kind of values as we see. These are kind of very interesting values. So what we can do instead is find the inverse, graph that one, and then make the table. So as we know, the inverse is just going to be followed by this formula right here. So it is going to be just 3 to the x power, which is pretty simple. We can do that. So when we make a table, I can go ahead and say, oh, -2, -1, 0, 1, 2, and 3. And I can right away just get the values that I want. So when I plug in 0 to my function, I'm going to get 1. Plug in 1, I'm going to get 3. 3 to the second power, 3 times 3. And 3 to the third power, 3 times 3 times 3 is 27. Then going backwards, 3 to the -1, I have to flip my numerator and denominator, so it's going to be 1 over 3. 3 to the second, we know 3 to the -2, we know 3 to the second is 9, so all we have to do is flip our numerator and denominator. So when I want to make the table for our log, all I have to do is flip my x's and y's. So my x's are not going to be y's. And my y's are not going to be at my x's. So I can just plug that in really quickly. And from there, simple graphing, right? So my log is in red, so I'm going to go ahead and plot those points down. At 1/2, it is -2. 1/3 is -1. At 1, it is 0. At 3, it is 1. At 9, it is 2. And we kind of stop there because we can't graph 27. So again, asymptote at x equals 0. Cool. Right away, we can graph this one. -2, it's at 1/9. -1, it's at 1/3. 0, 1. At 1, it's at 3. 2 is at 9. That's it. So I'd go ahead and graph this one as well. Is it symmetrical across the y equals x axis? And we can totally see it is, so we did this correctly. Now, simple part, domain and range. Domain are my x's, if we need to write that, and it's my left to right. So from left to right, my red log one, left to right, it is only going to go past the positive numbers. It's only positive numbers. We can't have negatives in our logs. So it is going to be x is greater than 0. And our range, we can see, are our y's, and we read it from bottom to top. Bottom to top, it's going to touch every single value. So all real numbers. My exponential function, from domain, left to right, it's going to touch every value, all real numbers. My range, however, it's only the positive numbers, only things bigger than 0. So y is equal to 0. And y is greater than 0. Notice how they're not equal to any of them because that's our asymptotes. So make sure you only write greater than. And that's it. This is how to graph logarithmic functions when you either have just your exponential or you have your log and you need to graph them. That's it.